Hello and welcome to this episode of Math with Martinez. We are in our unit on composition and inverses of functions, and today the skill we're looking at is CI2. We are using the composition of two functions to model and solve real-world problems. So let's begin. Composition is that first fill in the blank. The composition Whoa, that's really thick. Okay. It is a function operation that involves inputting an algebraic expression into a function. In the composition of functions, f and g is denoted as f of g. You're looking like that. And just so you know, this way in which we write it, the way that it's denoted, when I write f of g like so of x, that really means f of g of x, where whatever expression is the rule for g, that is going to be what is inputted into the rule for f. So, for example, let's look at these functions below. I want us to use blue to highlight our f function and green for our g function. And we're going to write a rule representing each composition. We're going to compose f of g and also g of f of x. So let's go ahead and begin. We want to start by rewriting this. This would be rewritten as, using our rule, this is f of g of x, which means we're going to take and into our f function, we're going to substitute the rule for g. That's the expression that's going to go inside of this function f. And so into the function f, notice that f is the quantity squared minus 9. That's the rule for our f function, that quantity squared minus 9. But what quantity are we going to work with? Well, that's what we need to input. In place of just the x, we want to take x plus 3. So we're substituting x plus 3, like it says here, in for x in f of x. That's what we're working on right here. That's what we've done. Just lining it up so it's more in line with my work. Now let's go ahead and simplify. That's our third step. To simplify, what are we going to need to do? Well, we're going to need to apply the fact that this binomial is squared. Make sure that when you have a binomial squared, that you take it times itself. All right, this is our simplifying. Then we'll use distribution. We'll say x times x, which is x squared. X times 3, that's going to be plus 3x. And then plus another 3x. Then last of all, plus 9. And then don't forget, you still have that minus 9 out at the end. Now we'll combine terms and simplify. We have only one squared term. We have our two linear terms, which combine to give us 6x. And then these two terms, actually, these last two terms are additive inverses, so they are going to undo one another or add up to 0, you could say. So we now know the rule for f of g of x. The rule for f of g of x is x squared plus 6x. That is the new rule for the composition of these two functions. Now let's look at g of f of x and apply the definition of composition for these. This is the same thing as saying g of f of x. So it is now the f function rule that's going to be applied inside of g. So inside of g, we're going to take and plug in that blue rule. We're going to substitute in x squared minus 9 into that g function. So our g function was the quantity, that input, and then plus 3. But what I want to do is instead of x, I'm going to plug in this blue rule, which is the rule for our f function. So that's x squared minus 9. And then our third step is just to go ahead and simplify. This is x squared minus 9 plus 3. Well, we can combine those last two terms, and it would be minus 6. G of f of x is x squared minus 6. There you have it, ladies and gentlemen. That's a brief review on composing functions, where we are taking and allowing the input into our function to be an algebraic expression. And I want you to notice here, this is something we're going to see more in depth in a future video, but notice that it does matter. It matters because our results here, even though we were working with the function f and g, when we did f of g, we had something different, right? The rule here is quite different from what we see for g of f of x. So you've got to be careful to set it up correctly. If you had any questions while you were watching this video, would you please take a moment to share those now? And until next time, stay fired up, you guys.